Hey guys, Mr. Middleton here. Today we're going to talk about multiplying and dividing by a monomial. At the end of this video, you should be able to multiply a polynomial by a monomial, and you should be able to find the GCF of a polynomial and divide or factor it out of a polynomial. So, recall from last lesson, if we have 5x cubed plus 2x cubed, we can simplify this because we're adding. They're like terms. They both have x cubes. Adding them together, 5 plus 2, 7, x cubed. Okay? The operation is addition, and the exponent does not change. Remember, the rule of thumb that I had is if they have to be the same, they have to stay the same. Okay, so for addition and subtraction, they have to be the same. Now, some review from last chapter. We have a to the fourth power times a squared. Remember, our rule is that when we have the same base and different exponents, when we're multiplying them, we can add their exponents. It gives us a to the sixth. Again, what operation is being used? In this case, it's multiplication. Okay. And does the exponent change with this operation? Yes, it does. And again, we didn't have to have the same exponent to start, so it can change. Okay, so summary, when adding or subtracting, remember those are essentially the same thing. If you were with me first semester, we talked about that a lot. Terms, when adding or subtracting terms, the exponent does not change, but in multiplication or division, again, essentially the same thing, of terms, the exponent does change. So let's go through a few examples of this. It says multiply each monomial into the polynomial. So basically we're going to distribute. Okay, we're going to distribute this 3 to each term. So we have 3 times x squared, which is 3x squared. 3 times 4x, which is 12x. 3 times 4 is 12. 3 times negative 5, negative 15. Check to see if there's anything we can add or simplify. We cannot, because again, when we need to add these, 3x squared and 12x, they have x's, but they're not to the same power, so we can't simplify by adding. Okay, and then this doesn't have x at all, so it's not like terms with any of these. So here's our simplified expression. 3x squared plus 12x minus 15. Alright, so next, do the same thing here. 4b times 5b squared. 4 times 5 is 20. b times b squared, remember there's an exponent here, so that gives us b to the third. Again, we're multiplying, so they don't have to have like terms to be able to multiply. Okay, again, going to distribute this. That'll give us 4b to the second. Okay, and then we have 4b. Okay, can't add any of these terms together. Again, they're different exponents, so we can't add them. Even though these look like they're about the same. This is b squared, this is b, so we can't put them together. So we have 20b to the third minus 4b squared plus 4b. Alright, doing one more with you. So 7 times 3 is 21. H to the third times h to the fourth is h to the seventh. 7 times 2 is 14. H to the fourth. 21 h to the seventh plus 14 h to the fourth. Alright, try number 4 out and bring that to class complete. Okay. Okay. Recalling. So, recall from 4th grade. This is stuff that you should have learned in 4th grade. We're just kind of bringing it out so we can use it here. Sorry, this is not even. Alright. So, list all the factors of 36. Remember, factors are numbers that we can multiply to get to 36 we'll use whole numbers. 1, I like to do it like this. 1 and 36. 2 and 18. 3 and 12. 4 and 9. And then 6. Okay. So we're basically just looking and saying, okay, what multiplies to give us 36? All those numbers. I always like to do the pairs, that way I don't mess up and forget something. And by the time I repeat a number, if a number multiplies by itself, then I know that I've gone through everything. Okay. Alright, so here it goes. It says find the GCF of 12 and 18. Remember, GCF stands for greatest common factor. Greatest, biggest, common thing alike. Okay? In this case we're saying factor. So the biggest number that is factors of both are all the numbers we're talking about. So 12 and 18. We could break this down and look at it like the long way, I guess, and say, okay, what are the factors of 12? 1 and 12, 2 and 6, 3 and 4. Okay. What are the factors of 18? 1 and 18, 2 and 9, 3 and 6, and what is that? I think that's it. 4, 5, yep. Okay, so then we say, what's the greatest common factor? What's the biggest number that they both have? Well, the greatest common factor in this case was 6. Alright, now that's not the process you have to go through each time, and hopefully that your multiplication facts are enough that you can recognize those without writing them out that way. Okay, let's apply it to algebra though. Okay, and again, I'll write it out this way for this time just so we can see the bones of it, and then we'll use our reasoning for the rest of the way. So we have 4x cubed, 12x squared, and 8x. 4x cubed, 12x squared, 8x. Now we're going to do this a little bit differently, just so we can work with it as we move on. So, as we're looking for the greatest common factor, another way that we can do this, instead of listing out all the factors, is we can factor the numbers on their own and basically say what multiplies to give us these numbers. So what multiplies to give us 4, 2 times 2 times x times x times x. Okay, so that's 2 times 4, 2, 4, x times x times x, x cubed. What multiplies to give us 12? Okay, well that's 3 times 2 times 2. Okay, x and x. Multiplies to give us 8. 2 times 2 times 2. X. Okay, and then what we'll do is we'll take these factorizations and we'll circle everything that's common between all of them. So like I noticed that all of them have 1x. At least 1x, let me say it that way. Okay, now notice that 4x cubed and 12x squared have another x, but 8x does not. So there's, as far as our commonalities go, we can only circle 1x. Now we're looking for something else that all of them have. Well, they all have at least 2 2's. Okay? Now as we look at these numbers, there's nothing else that they all have in common. And so when we're writing our factorization, our GCF is going to be 2 times 2. They all have 2 2's as factors. And x. So our answer there is 4x. That's our greatest common factor between these numbers. Okay, so two ways that we can look at greatest common factors. This one might be a little bit more helpful in the sense of going back and correcting your word, checking and seeing that you have the correct word. Alright, so let's see if we can do that with some more examples. We have 4x to the 5th plus 10x to the 4th minus 14x to the 3rd. Now, as I would tell you to look at it the same way that I tell you to multiply monomials, is to focus on the numbers, then focus on the exponents. So I'm looking at 4, 10, and 14. And I say, what's the biggest number that goes into all of these? Okay, they're all even, so 2. Looking at 2. And then as I look at the other numbers, 2 and 5, 2 and 7, 2 and 2. Okay, so they all just have 2. So our GCF between the numbers is 2. And now as I look at the exponents, x to the 5th, x to the 4th, x to the 3rd, this is a little bit easier. I say, do they all have x's? Yes, 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 they all have x's. What's the lowest number? 3. They all have at least 3 x's. So our GCF is 2x cubed. Okay, so that's the faster way to do it. Now, if you don't feel comfortable with that, then for the first few days you could, if you wanted to, which this would be more drawn out. You could go through and say, okay, 2 times 2, and then x 5 times. 2 times 5, and then x 4 times. 2 times 7, and then x 3 times. And do what we did just in this previous example. 3x is here, 3x is there, 3x is there. Alright, 2, 2, 2. Okay, is there anything else they all have in common? No. What does that come out to be? 2x cubed. Okay. Try it with number 2. Now, let's look at number 3. We have 4x cubed plus 6x squared minus 3. As we look at the GCF here, again, I tell you look at the numbers and then look at the variables. As we look at the numbers, we have 4, which is 2 and 2, 6, which is 2 and 3, and then 3, which is just 3. You should notice that, wait a second, there's no numerical factor that they all have in common. These two have 3s, these two have 2s, but there's nothing that everything has. So our GCF as far as numbers go is 1. As we look at the variables, we have x cubed, x squared, but there's no x here. So they don't have a variable factor that's in common. So our GCF here is just 1. Okay, and that's typically what we'll have if we can't factor. Okay, finding the GCF is only the first step in factoring or dividing a polynomial by a monomial. The second step is dividing each term by that GCF. Okay, so let's see how we'll do it with these problems down here. So for number 1, I'm going to look and I'm going to say, what's my GCF? So between 6, 12, and 9, say, okay, 3 goes into all of those. X cubed, x squared, x. So my GCF is 3x. And now what I'm going to do is I'm going to go through each term and I'm going to divide it by 3x. Now we should know how to do this because we've done this in the last chapter when we were doing our exponent rules. Now when I factor, the rule is that my factor should be able to multiply back into my original problem. So the GCF that I took out, I'm going to make sure I include it in my final answer. GCF was 3x. Okay, 6 divided by 3 is 2. X cubed divided by x is x squared. 12 divided by 3 is 4. X squared divided by x is x. 9 divided by 3 is 3. X divided by x is, well, the x's would be 0, so the x would just be 1. And so here's my final answer. When I get to the final answer factoring problem, I want to make sure that there are no common factors left inside my parentheses. If there are common factors left inside my parentheses, that means that I did not take out the greatest common factor originally. Okay? So here, I look at the numbers 2, 4, 3. These both have 2's, but then 3 doesn't have anything to go with those. Okay, x squared, x, nothing. Okay, so these both have x's, but there's no x here. So there's no factor that's common between all of our terms. So we're done. Okay, let's look what happens if we don't take out the greatest common factor at first in this problem. Okay, so if I look at this problem and say, okay, they both have 2x squared. 8 and 12, they're both even. I'm going to take out 2x squared, and I say, okay, my GCF is 2x squared. And then I factor 2x squared out of these things. So I'm going to divide by 2x squared, and I have an answer of 2x squared, and that will give me 4x cubed minus 6. Okay, at this point I should look in here and say 4 and 6, hold on, they have a number that's even. They're both even, so I should be able to fit 2 in there again. Okay, I'm going to take out 2. What happens if I factor something out of here? Remember that I want to keep it in my problem. Okay, I want to keep it in my problem so that I can multiply it back to the original expression. But this is all I have to do. If I say, okay, wait, these both have factors of 2, I can take it out of here by dividing by 2, and to keep the problem balanced, that means I'm going to multiply the outside by 2. And so what I have is 4x squared, and then in parentheses, 2x cubed minus 3. Now you'll notice in the parentheses 2 and 3, there's no common factors there. X cubed and no x here, so there's no common factors there. This will be my final answer. Okay? But you want to take your time and get the biggest GCF out the first time if possible. Alright. Number 5. We look at this, we have 5 and 20, so 5 goes into both of those. This says d cubed, and this one doesn't have a variable, so 5 is our GCF, d cubed plus 4. 2x cubed plus 5x cubed, or sorry, 2x to the 4th plus 5x cubed minus 6x squared. So look at the numbers, 2, 5, 6. There's nothing that goes into all of those. You have x to the 4th, x to the 3rd, x squared, x, they all have x's. So x squared would be that number. I'm going to divide everything here by x squared. And so that's my GCF, right on the outside. And then inside I have 2x squared plus 5x to the 1st minus 6. And I look and say, is there anything that goes into all these numbers? Nope. So I'm good. Alright, number 5, we're going to try to factor this GCF out. As we look, we have x squared and x here, so but no x here, so there we can't take a variable out. And then we have 1 in front of a number. So anytime there's 1 in front of a number, we, know that there is no other GCF. Factoring out 1 will not do anything for us. And so this is factored right now as far as we can't take any GCFs out. And so at this point, this is all we can do. Later, we will talk about how to factor quadratics or polynomials like this. Alright, you got one problem left. Try number 6. Find out the GCF. Separate, look at 6, 12, and 18. Find the GCF between those, between p to the 5th, p to the 4th, and p to the 3rd power. Factor it out and leave your expression here. Okay? Alright, see ya.